In the last part of my talk, I shall consider what are known as giant segmented mirror telescopes. Astronomers always try to build as big a telescope as they possibly can. Uh, they are limited only by technology and by the availability of funds because it can get very expensive to build bigger and bigger telescopes. But by taking advantage of improving technology, for example, by splitting one large mirror into a number of segments, there can be great savings in cost. Because each segment is light, segment can be made independently and then it is stuck together. On the other hand, a great deal of intellectual effort, technology, and also funding goes into making the active components which are required, the electronic components and the correctors and actuators which are required to keep all these segments into one single mirror properly shaped. And I've also mentioned to you that we need to make corrections for the turbulence of the atmosphere, which is known as adaptive optics. So, using all these new technology, there are now plans to build very large telescopes. There are three independent projects, and I shall show you a few slides of them and describe each of these projects to you very, very briefly. The smallest of the three telescopes is known as the Giant Magellan Telescope. There are two Magellan telescopes in extant now, which are much smaller diameters, but the GMT, as it is known, would consist of 7 mirrors, each 8 meters in diameter. Now, this project, like the other two as well, is a consortium of institutions from several different countries, and is led by the Carnegie Observatory, which is located in Pasadena. Now, here is a close-up of the mirrors, so of the telescope primary. So this is not ready yet, and this is just an impression of what it will look like when it is completed. So you see that there are 7 mirrors here, and then they are all they together form a single surface. It is very difficult optically to achieve this because each mirror itself is rather large, and it has to be very carefully shaped so that it forms one segment of a much larger mirror. Now these are all mounted together in what is known as the altazimuth mount, okay, which necessarily requires computer control for its operation, but which becomes much lighter than the traditional mounts in which telescopes of the earlier era were made. The telescope, this one will be located in Chile. It will have an equivalent diameter of about 23 meters and will allow us to carry out observations of very distant extragalactic objects. Now the next telescope in this series is known as the TMT, which stands for the 30-meter telescope, which is again a consortium of astronomers from several countries, which is led by Caltech, which is also located in Pasadena, the California Institute of Technology. And the TMT, as its name says, will be 30 meters in diameter. So it has got the very large number of segments. They are more than 500 in number, which are again stuck together, controlled with active optics to maintain its shape. So both the GMT as well as the TMT and the European Extremely Large Telescope, which I will show you in a moment, they will represent great strides in telescope technology, because the telescopes are so large that the control systems will get very complex. Moreover, adaptive optics is being planned into the system right from the inception rather than putting it as an add-on later, so which also makes the design much more difficult, but the images will be very beautiful and sharp. So the TMT is located in Hawaii, and the last telescope that I show you here in this series is known as the European Extremely Large Telescope, and as its name suggests, it will be significantly larger than the other two and will have an effective diameter of 42 meters. Now this too is located in an observatory in Chile. So you see that these three telescopes, which are expected to go in operation around 2018 or 2019, will lead to astronomers taking a new step into the unknown. Because the kind of objects which will be visible here and the kind of detail in known objects which can be studied will be quite extraordinary. It will be backed, it will have to be backed, the data which is collected will be very voluminous, a great deal of data will become available every night, and the images will be very large formatted, and the image analysis will itself be a very formidable affair. But so therefore there will have to be improvements made in all these departments. And large data centers and science centers will have to be set up so that astronomers from all over the world get access to all this wealth of data. And we hope to make many new discoveries using these large telescopes, exactly like Galileo did 4 centuries ago.